What exactly lies at the edge of the observable universe? Well, this has remained a mystery for centuries, fueling curiosity and speculation among scientists and enthusiasts alike. However, the James Webb Space Telescope holds the key to unveiling this cosmic mystery. With its powerful lenses peering deeper into space, it has recently made a groundbreaking announcement of what lies at the edge of the observable universe. When we talk about the edge of the universe, it's essential to understand the concept of the observable universe. The observable universe includes everything that we can see, measure, and study from Earth or our space-based telescopes and exploratory probes at the present time. It consists of stars, galaxies, and other celestial objects that are within our observational reach. So, what's the difference between the universe with a capital U and the observable universe? In simple terms, the observable universe is just a small fraction of the entire universe that we can study and comprehend. While the complete size and shape of the entire universe are unknown, there is an estimated diameter of the observable universe which is around 93 billion light-years. Now, a light-year is a unit of distance that light travels in 1 year, which is about 5.88 trillion miles or 9.46 trillion kilometers. So, the diameter of the observable universe, 93 billion light-years, is an unimaginably vast expanse spanning approximately 546.84 billion trillion miles or 878.58 billion trillion kilometers, showcasing the mind-boggling scale of our cosmic surroundings that's difficult to even comprehend. But why is the universe so incredibly vast? The answer lies in its origins. The Big Bang Theory tells us that approximately 13.8 billion years ago, the universe was born in a powerful explosion. This explosive event triggered a rapid expansion, and since then, the universe has been expanding at an increasingly faster pace, driven by enigmatic forces like dark energy. As the universe expanded, particles of matter started clustering together due to the force of gravity, forming awe-inspiring structures such as stars, galaxies, and eventually even planets like our beloved Earth. Over countless years, these cosmic structures grew larger and more intricate, leading to the extraordinary diversity of objects and phenomena that we observe throughout the universe today. Despite the vastness of the universe, it is predominantly empty. To put it in perspective, if we scaled down our entire solar system to the size of a quarter, the nearest star would still be the distance of 2 soccer fields away. And this is just within our Milky Way galaxy, which is one among billions in the observable universe. You may wonder, why can't we see the entire universe? There are 2 factors that explain this. The first reason is that light takes time to travel through space. When we look at distant objects in the universe, we are actually observing them as they were in the past. The farther away an object is, the longer its light has taken to reach us. So, by observing distant galaxies, we're essentially peering back in time, unraveling the history of our cosmos. The second reason is the universe's expansion. Imagine dots on the surface of an inflating balloon. As the balloon expands, the dots move away from each other. The same principle applies to the universe, where galaxies are drifting apart as space itself stretches. This expansion causes the light from distant objects to become stretched too, shifting towards longer wavelengths, which we perceive as redshift. Eventually, some objects will move beyond our observational reach as they recede beyond a certain distance. Considering these factors, it's not surprising that we haven't seen the entire universe yet. Now, the concept of the edge of the universe is a mind-boggling topic that has fascinated scientists, philosophers, and thinkers for ages. We have all sorts of theories about what lies beyond, but the truth remains elusive. However, there are 3 theories that stand out. The first theory is that the universe goes on forever, with no end in sight. This theory is based on the cosmological principle, which states that the universe is isotropic, meaning that it looks roughly the same in every direction. If this principle holds true, it implies that the universe stretches on endlessly without a boundary. The second theory suggests that the universe is finite, but it doesn't have a clear edge either. This means it's similar to a giant ball, and if you keep going in any direction, you'll eventually loop back to where you started. The third theory is the multiverse theory, which suggests that our universe is just one of many. Imagine a bunch of parallel universes, each with its own set of rules and properties. These universes could be completely separate from each other or somehow connected. So, we've talked about concepts surrounding the edge of the universe by looking at diverse theories. Now let's turn our attention to a remarkable tool that holds the potential to shed light on these mysteries, the James Webb Space Telescope, JWST. This incredible telescope allows us to look far back in time and discover unexpected objects from the early days of the cosmos. The JWST, with its advanced capabilities, has enabled astronomers to peer back into the early days of the universe. And guess what? They've stumbled upon something unexpected. In a recent study published in the journal Nature, the JWST discovered 6 massive galaxies that existed between 500 million and 700 million years after the Big Bang. Researchers were only expecting to find small, newly formed galaxies, but the JWST caught them by surprise. These galaxies are way larger than anyone ever imagined, challenging what we thought we knew about the early cosmos. But that's not all. Scientists also found something mind-boggling. These galaxies are as mature as our 13-billion-year-old. The James Webb Space Telescope, JWST, has unveiled a stunning revelation about our universe. It has detected several colossal galaxies, each containing a mass of stars several billion times larger than our Sun. One of these galaxies may even boast a mass 100 billion times greater than that of the Sun. For comparison, the entire Milky Way galaxy holds a stellar mass equivalent to roughly 60 billion suns. What's truly remarkable about the JWST is its ability to perceive the invisible using infrared light, capturing the faint glow of ancient stars and galaxies that have existed for eons. This capability allows the telescope to transport us back in time, offering a glimpse of the universe as it appeared around 13.5 billion years ago. This discovery has upended our understanding of early galaxies, challenging previous models that suggested galaxies began as small clusters of stars and dust, gradually growing over time. Dubbed universe breakers, these gigantic galaxies defy 99% of our existing models. When researchers first encountered them in the Webb's data and high-resolution images, they were stunned. The sudden emergence of these colossal objects, appearing as significant points of light, left scientists questioning their own interpretations. Through spectroscopic analysis, scientists hope to unravel more about these galaxies, including their composition, size, and distance from Earth. Interestingly, this groundbreaking discovery wasn't even among the top priorities for scientists using the James Webb Telescope. It exceeded expectations and unfolded much faster than anticipated. Moreover, there's a possibility that some of the objects detected in the Webb data might be something entirely different, such as hidden supermassive black holes. This revelation has also led to a significant reassessment of the total stellar mass in the universe, now estimated to be up to 100 times greater than previously believed. Meanwhile, utilizing the JWST, an international team of astronomers has made another remarkable discovery, the oldest and farthest galaxies ever confirmed. These galaxies offer a glimpse into a time when the universe was just a fraction of its current age, less than 400 million years after the Big Bang. The light from these ancient galaxies reached us over 13.4 billion years ago, as detected by the telescope. The initial images captured by the James Webb Space Telescope, JWST, revealed numerous potential galaxies, following in the footsteps of observations made by the Hubble Space Telescope. Through meticulous spectroscopic observations, astronomers have now confirmed 4 of these objects. This confirmation not only enables the study of the physical properties of these galaxies but also facilitates the accurate determination of their distances. Astronomers determine a galaxy's distance by calculating its redshift. Redshift occurs as the universe expands, causing objects to appear to move away from us, which stretches their light toward longer, redder wavelengths, a phenomenon known as the Doppler effect. While redshift estimates can be derived from photos taken through various filters, spectroscopy offers a preferred method for obtaining precise measurements by breaking down the object's light into its constituent wavelengths. The focus of these new discoveries is on 4 galaxies with redshifts greater than 10, indicating their extreme distance from us. The James Webb Space Telescope revealed 2 galaxies with even higher redshifts, 13.20 and 12.63, corresponding universe. Thanks to a time period roughly 13.5 billion years ago, unveiling ancient cosmic history. Additionally, the JWST Advanced Deep Extragalactic Survey, JADES, is an ambitious program aimed at providing an unprecedented, in-depth glimpse into the early cosmos. Proposed in 2015, JADES involves an international partnership known as JADES, comprising more than 80 astronomers and scientists from 10 different nations. By utilizing instruments like NIRCam and NIRSpec, the JADES team has made remarkable discoveries, including nearly 100,000 distant galaxies, each billions of light-years away. The spectroscopic data collected during these observations enables scientists to reveal the characteristics of the gas and stars within these galaxies and obtain precise redshift values. With these measurements, astronomers can determine the intrinsic brightness of the galaxies and estimate the number of stars they contain, facilitating a comprehensive examination of galaxy formation over time. Studying galaxies presents challenges akin to understanding human beings, as the early generations of stars profoundly influence the future evolution of galaxies. This is an extraordinary time in history when the transformative capabilities of the Webb telescope are answering numerous questions about galaxies. NASA's Deep Space Observatory telescope is revolutionizing our understanding of the cosmos and unveiling a treasure trove of new discoveries. The James Webb Space Telescope, Webb, a pioneer in scientific research, is providing us with astonishing insights into galaxies, planets, stars, and other captivating cosmic phenomena. Launched in December 2021 and expected to operate for 2 decades, Webb is just embarking on its cosmic adventure, surpassing the standards set by its predecessor, the Hubble Space Telescope. Webb has captured the imagination of scientists and the public alike, inspiring a wave of scientific enthusiasm. People worldwide are eagerly modifying the telescope's raw data, sharing its breathtaking photos, and gaining fresh perspectives. Following a flawless deployment process, Webb astonished us with its initial photographs in mid-July, granting us an unprecedented view of our universe's myriad aspects. With the help of its advanced infrared telescope, we can explore the farthest galaxies in remarkable detail and peer into the depths of the past. Within days of going online in late June 2022, Webb's powerful instrument started revealing thousands of previously unknown galaxies, older and more distant than ever imagined. Moreover, the telescope's capabilities enable scientists to gather abundant light from celestial objects, such as exoplanets and newborn stars, unveiling their compositions and tracing their trajectories through space. This wealth of data is already unveiling intricate details about the atmospheric compositions of planets located hundreds of light-years away from Earth, hinting at their potential habitability. But not just that, by analyzing faint traces of light from the universe's infancy, the James Webb Space Telescope has potentially identified the oldest black hole ever observed. This supermassive black hole, with a mass 9 million times that of the Sun, resides at the core of a young galaxy that formed 570 million years after the birth of the universe. Thanks to Webb's powerful cameras, capable of peering back in time to the cosmos' earliest moments, this monumental discovery offers insights into the cosmic dawn when numerous black holes grew in size over the course of 1 billion years following the Big Bang. The origins and proliferation of these enigmatic cosmic entities remain mysteries that puzzle astronomers. Some of these massive cosmic disruptions emit light observable by telescopes, created by the friction of material spiraling into their gravitational abyss. These objects, known as active galactic nuclei, AGN, supermassive black holes, or quasars, are billions of times more massive than the Sun, radiating intense bursts of light, trillions of times brighter than the brightest stars. They represent the most extreme form of AGN. As scientists venture deeper into the cosmos, they can capture light from more distant sources, providing glimpses into earlier stages of the universe. The James Webb Space Telescope, JWST, employs its mid-infrared instrument and near-infrared camera to scan the sky, searching for black holes. Its built-in spectrographs then separate the light spectrum into different frequencies, allowing scientists to analyze the data. During their investigations, scientists made a crucial discovery. The heated material surrounding a black hole emitted faint traces of radiation across the universe. By scrutinizing these delicate glimmers from the universe's infancy, they detected an unexpected surge among the frequencies embedded within the light, providing valuable insights into the cosmic processes at play. The rapid appearance of black holes in our young cosmos remains a mystery. Scientists continue their search for much younger primordial black holes, which are believed to have formed right after the Big Bang or possibly even earlier. However, these elusive objects have yet to be discovered. Meanwhile, two main explanations exist for the abundance of black holes in the present universe. One possibility is that they are remnants of massive stars. Scientists have proposed various theories to explain the formation of enigmatic black holes in the universe. One possibility is that they are remnants of massive stars that formed much more rapidly than the stars we observe today. Alternatively, it's suggested that dense clouds of gas suddenly collapsed to form these enigmatic singularities in space-time. A more probable scenario involves a population 3 star, a hypothetical class of stars that emerged about 200 million years after the Big Bang, primarily composed of hydrogen and helium. Such a star would have exploded, leaving behind a black hole. Subsequently, the black hole would have grown in size by rapidly accumulating matter at a rate exceeding stability. Scientists are collaborating with the team behind the development of MIRI to study the far-off galaxy's light and seek additional clues about the formation of the enigmatic black hole at its center. Additionally, scientists have examined the early stages of the universe and observed the formation of a protocluster comprising 7 interacting galaxies. This cluster, discovered by the Hubble Space Telescope, is the most distant galaxy cluster identified by researchers. Simulations suggest it will eventually become one of the oldest and largest known galaxy clusters in the universe, with a mass nearly 100 times greater than that of our Milky Way galaxy. While the initial discovery of these galaxies was made by the Hubble Space Telescope, it lacked the sensitivity to precisely measure the distances between them, despite their alignment along the same line of sight. However, thanks to the James Webb Telescope, scientists gained a much clearer picture. These kinds of clusters are extremely unusual and difficult to locate. Although it's unlikely that the JWST will discover another unique system like this, the future Nancy Grace Roman Space Telescope, set to launch in early 2027, will enhance our ability to identify galaxy clusters in the early universe. Its wide-area survey capabilities will surpass the JWST by over 100 times. Additionally, the James Webb Space Telescope has played a crucial role in groundbreaking exoplanet discoveries since the 1990s. We now know of over 3,000 extrasolar planets, although only a dozen have been directly photographed. Most exoplanets are so distant that we can only observe them when they transit in front of their host stars, causing a slight dimming of light. However, the JWST has changed the game by allowing scientists to directly observe exoplanets. The James Webb Space Telescope, Webb, has revolutionized our understanding of exoplanets and distant celestial objects. Equipped with advanced technology such as coronagraphs, cameras, and filters, Webb enables scientists to directly observe exoplanets. In 2017, the Sphere Consortium identified HIP 65426b, an exoplanet orbiting its host star, HIP 65426. This exoplanet gained further attention in September 2022 as the first to be directly observed by the James Webb Space Telescope. HIP 65426b's unique characteristics, coupled with Webb's remarkable sensitivity, make it particularly intriguing. Situated at a distance from its host star 100 times greater than the distance between our Sun and Earth, HIP 65426b is a colossal gas giant, about 12 times the size of Jupiter. Webb's infrared camera captures the elusive brilliance of the phantom galaxy, revealing its stunning spiral shape and the dispersion of stars. Combining data from the Hubble Space Telescope and Webb, researchers have created breathtaking composite images, offering a comprehensive understanding of galaxies. Webb studies have also provided insights into dust particles in interstellar space and captured images of distant stars like WR-140, surrounded by unique ring formations. Moreover, Webb has contributed to the study of exoplanets like WASP-39b, a scorching gas giant orbiting its host star at a close distance. Designed to explore the farthest reaches of the universe, Webb has confirmed its success in uncovering the mysteries of the cosmos. Subscribe for more updates and see you in the next episode.